Hello everyone, welcome back. So let's continue with exception handling. So before diving deep into exceptions, let's see what's the basic difference between exception and syntax error. So syntax errors occur when the parser detects an incorrect statement. So let's run this cell. So now we got a syntax error. So the arrow indicates where the parser ran into the syntax error. In this example, there was only one bracket, which was an extra bracket. Now let's remove it and probably let's run again the code. Now again we've got into an error situation. Now this time we ran into an exception error. This type of error occurs when syntactically correct Python code results in an error. There was no syntax error, but still we got an error. Now this type of error is called a exception. Now here the Python tells us what kind of exception it is. So it's a zero division error. That means we are dividing by 0, which is not allowed. Okay, now let's study some popular methods to handle exception. So in Python, we handle exceptions using a try and except block. The try and except block in Python is used to catch and handle exception. So Python executes code following the try statement as a normal part of the program. So whatever you wish to write here, wish to write as a code, you write the try block. And if something fails in the try block, the program would not throw an error, rather it would go to the except block. And this part of the code will be executed whenever there is an exception. So you need to think about when you could occur into an exception situation, and accordingly you need to think what should be the catchphrase for that exception. So the code that follows the except program statement in the program's response to any exceptions in the preceding try clause. So whenever the try fails, you go into the except part. Now, as you saw earlier, when syntactically correct codes run into an error, Python will throw an exception error. This exception error will crash the program if it is unhandled. If you do not, let's say, you do not put a try and except block, you would run into a error situation, right? It will throw an error. Now let's look into a very simple example to understand what, uh, like how could we handle this exception. So earlier we saw the zero or division by zero exception. Let's write a function, very simple function, which returns the division between two numbers. Right. Now let's see when we input a as 10 and b as 2. So this is how we write try and except. In the try, we are just calling the function, we are printing its value. In the except, we are printing that the value entered for the function is not valid. Now let's see. When we run this code, it goes into, let me also print something like entering the try block. So it has entered the try block and it has printed 10 divided by 2, which is 5, which is 5. Now let us change the value of b as 0 and then let's try to rerun the code. Right. So what does it happen? Now it is entering the try block, but as soon as you encounter this, it will call the divide function, and as soon as there is an error, exception error, it will go to the except block and it will print enter the valid value. So it has gone into the try block first, and then when the exception occurred, it went into the except block. Okay. Now let us look. You must be curious as to what the exception is, right? So what Python sort of gives us is we can name the exception as an argument, let's say, which is e, and we can also print e. So let me rerun it. Now when I rerun it, it shows me division by zero error. Exception is the division by zero error, and we've also printed enter the valid value. So exception could be many, could be of various kind. Let's look at some other kind of exception here. Now in this code block, what we're trying to do is we are trying to open a file which is not present in our system, right? And we're trying to read that file, but this file is not present in my system. Now let me run this code. So when I run this code, I get an exception which is no such file or directory, and Python has also given me the file name, right? And I have printed for just for the logging purpose that I cannot open the file. So exception is a good way to handle any anomalous situation which you can encounter in your program. So let's see what are the key takeaways from try clause and except clause. So a try clause is executed up until the point where the first exception is encountered, as we saw. Inside the except clause or the exception handler, you determine how the program responds. So let's say we are, in this case, we are just mm, letting the programmer know that there is no such file or directory, or you cannot divide by zero, right? You can anticipate multiple exceptions and differentiate how the program should respond to them. So program could have multiple try and except blocks depending upon what kind of logic one is trying to implement. Right, now let's look at very interesting concept of the else clause. Now we know what is try and what is except, but let's look at what is this else thing. So every time the program runs, it will first go to the try block. It will run this code. If there is an exception and the program fails in try, it will go to the except block. It will execute when there is an exception. And in the else block, it will go when there are no exceptions, or even when there is exception, it will also go to the else block. So else block will always be executed no matter what, right? Correct. Okay. Now if uh if there is an exception, the else part would not be uh else part would not run. Rather, you would just have to execute the except part. So the else part would not run. Now let us look into an example. We have defined a function wherein we are trying to sort of see if our system is Linux or not. Now this is a Mac system, so let me just print out sys.platform for you for my system. So it's a Darwin system, which is alias for Mac. Now when I run this function and when I run this in the try and except block, let's see what do I get. So what happens is it goes into the try, it tries to run this function, it goes into this function. Now assert says that it will only run if this statement is true. Now if this statement is not true, so it returns that function can only run on Linux system. So if the system is true, it would pass, but if it is not true, this is what we are returning, right? Now, else part is not executed here. Why? Because we got into the exception. Else part is not executed when there is an exception. Remember this again. Whenever there is an exception, else part is not executed. Now I have another function here which is a back interaction wherein I have asserted if Darwin is there in the system.platforms output. Now let me run it again. So when I run it again, what I see here is let me show you the entire flow. So it goes into the try block. It runs this function back interaction. Now we are not into any error because this statement ran, right? And we have printed successfully doing something. So doing something is printed. So we are not going into the else block or except block. Now we would go into the else part. Now in the else part again we have a try and except block, right? So we can have multiple try and except block for different kind of logic. Now we are trying to read this file which is not in our system, right? Now again we are using the try and except. Now since this file is not in the system, it would go to this except block, right? And it would throw an error. So this error we have printed in no such file or directory, which we earlier saw. So this is what try, except, and else part do. So the program goes into this try. If it successfully runs, it would go into the else. Let me try to annotate it if I can. So program enters into try, and if successfully it runs, it would go into the else part. If it ran successfully, right? And if there is no success, then it would go to the except block. If it in case fails, it would go to the except block, and then the else would not be executed in that case, right? So this is what try, except, and else does for us. Okay. Now let us look into another piece, which is after try, except, and else. It is called finally. Now here, what the difference between else and finally is, else would only run if there are no exceptions, but finally would always run. So finally would always run no matter what. Even if your code fails in the try, it would directly jump into this. It would go to exception, run the exception, and then go into the finally, right? So this would be the flow. Let's look into an example. So again, I'm trying to run this Linux interaction function. Now we know that it would go to the exception part, right? So in the exception, it would print the error. And once the exception is reached, it would not go into the cells, right? So it is not going into the cells. It would then finally go to this finally part where we are printing something which shows that it's going into the finally block. Let me run it. So the output is function can run only on Linux system, which we already asserted for our Linux interaction function. Now, after going into the exception, it would not go into the else block, but rather go to this finally block, and it would print cleaning up irrespective of any exception. So that's what we have also got as an output. So this is what the entire concept of try, except, else, and finally is. Let's look another small but rather useful concept of the argument of an exception. So the argument of an exception is you write try block, you do your operation, and then you basically write except exception type as your argument. So this is your argument, right? This is previously we have written except exception as E, something like that. That is, let's say, file not found error as FNF error. So this is the name of the exception. If you want, you can also write a generic name for the exception as exception. If you do not know beforehand what kind of exception you can head into. So you can write a generic name exception, right? So you pass this as an argument, and then you can print this. Let's look at an example. So this is a very simple example to convert a variable into an integer. When you accidentally pass this function as this function string, it would not be able to convert the string into integer. Rather, it would go into an exception. And so what it would print? It would print the argument does not contain numbers and the kind of exception. So the exception is invalid literal for integer with base 10. Right? So it's saying that this input XYZ is not valid to be converted into an integer. Right? So there are various built-in exceptions in Python. I mean, you can read, probably you should read about all these exceptions. Few of them we have already seen. Here, value error, then file not found error, then division by zero error, assertion error. So we have seen couple of them, but then I would encourage you to go and read about all the other exceptions, uh, which we usually use in our try and except system. Okay, so memory error is one common exception which you get when your memory overflows, right? So let's move into the last part of the lecture, which is the user-defined exception. So Python allows us to sort of uh, raise an exception, right? With a choice of our own sort of messaging thing. So we use this with the help of a keyword called raise. So raise is a keyword where we sort of use this to raise our own kind of exception or whatever we feel. So let's say if somebody inputs a number greater than 5, we can raise an exception that the number should not exceed 5 and probably we could also print the value. So let's run it. So let's run it for probably, let me write a else here also. So the number was less than 5. So let me change it to 1. So it goes into this else. It compares, first it compares 1 with 5. So 1 is less than 5. It goes into else. Prints the number was less than 5. Let me change it to 10. Okay, interesting. Now it raises an exception, which is the user defined exception. You will not find it in the Python's inbuilt library. and it has raised an exception that the number should not exceed 5, right? And the value of, of this x variable was 10. So this is a very efficient way to raise custom defined exceptions. Now assert is another interesting concept. So instead of waiting for a program to crash midway, you can also start by making assertion in Python. We have already used assertion, but let's now look into some more detail. So we assert that a certain condition is met. If this condition is true, then excellent. The program can continue, it would run. If it turns out to be false, then the program throws an assertion error exception. So again, let's look at this example. So I've printed system.platform as Darwin, it shows Darwin. Now let me assert. So I'm asserting if Linux is contained in this string system.platform, then so this would only run the statement would only run if the Linux is contained in this string, whatever this system.output, the system.platform is outputting. If this statement fails, then show this. This is what assert does. Assert does. So let's run this. So this code runs on Linux only because our system.platform gives Darwin. If we write Darwin here, nothing happens. It just passes. Right. So this is what assert keyword does. Let's quickly see to the summary what we've learned. So raise allows you to throw an exception at any time. It's a user defined exception. Assert enables to verify if a certain condition is met. If it's not met, then throw an exception. In try clause, all the statements are executed until an exception is encountered. Except is used to catch and handle exceptions if found any in the try clause. Else lets you code sections that should only run when there are no exceptions. So if there are no exception in the try, then you would run else. And lastly, finally block enables you to execute sections of the code that should always run, irrespective of whether you have encountered any previous exception. Right. So I hope exception handling is now very much clear to you. I would encourage you to start building a habit to write code using try and except blocks, try except else finally, whatever you have learned here, which would help you make a better Python program. So thank you everyone for watching the video. Have a nice day.